Okay, so let's do an example on centripetal force. So in our problem here, in a circus performance, a stunt of riding a bicycle in a loop-loop was introduced. The radius of this circle is 2.7 meters. What is the minimum speed needed to maintain contact with the loop? So to kind of give us a little visualization here, we have a bicycle, and as it rides, it's going to go through the stunt, and there's my loop for you guys. And the way this bike travels, it has to go through the loop here. Now, if you're too slow, you won't even go up the hill, and if you don't, if there's a possibility to go fast enough to go up the hill, but if it's not fast enough, there's this point where you can kind of fall off the loop, which would be the opposite of a stunt. And of course, there's a certain speed to maintain to successfully complete the loop in a safe manner. So in this problem, they want us to determine what is the speed minimum needed to sort of complete this loop. So let's go. Let me kind of make this font a little smaller here. Oops, here we go. Go to. Alright, so same problem. So the main thing we are concerned about is the stunt person at the very top of this loop. Right, so let's do this. So here's our loop. It'll be a perfect circle for now. And the part that we are most concerned about is the stunt person at the very top. So let's say that there's our sort of free body diagram. Right. And since we're talking about an object staying in a circular path, we are certainly talking about centripetal force here. So centripetal force is part of our situation here. So FC, let me just write that down on the side. So centripetal force is present. And recall that centripetal force is defined by the mass times the tangential speed squared over the radius, or how far it is from the center of this circle. Alright. And I probably could have wrote that a little bit smaller, but anyway, in our problem, if this is our stunt at the top of the loop, we kind of have to identify, well, what are the forces present in this? Well, if you look at this, the main thing we are certainly concerned about is force of gravity, because this is the force that's going to cause the stunt person to fall down. So there's certainly a force of gravity concern here. All right. Right. Now they're not mentioning anything about friction, so in terms of friction, I don't think it would have anything in terms of the vertical direction here. What we do, well, there is certainly one other force involved aside from gravity here, and I know it's hard to think about it this way, but this bicycle is touching a surface, and if it's touching a surface, that means that there must be a normal force. Right, but normal force isn't what we're used to. We're used to pointing up or at an angle. Normal force is opposite or perpendicular to the surface. In this case, the surface is above us. So normal force would in fact be pointing this way. All right, and let me go ahead and label those, otherwise we might forget. So here we have normal force is also pointing downwards. All right, and then we also have a force of gravity pointing in the downward direction. There we go. So these are the only two forces present. And they are also both aimed at the circle, or aimed towards the center. And we have to consider, well, we need to consider the minimum speed here. This is what we need to figure out. But these two forces, the only forces there, and these two forces are what makes up this sort of centripetal force, which is maintaining it in a circular motion. Alright, so if we think about this, well, therefore we're trying to say centripetal force is the combination of the normal force and the force of gravity. But since we're talking about barely maintaining a contact with the loop here, if we're saying that the biker is barely touching the surface, then that would almost imply that the normal force is more approximately a little bit. I'll make that a little smaller. The normal force would, if you're barely touching the surface, that means the normal force, there barely is any normal force at all, so the normal force would be 0 newtons. So if we go back to our equation here, the central force is the combination of the normal force and force of gravity. Normal force is, well, it's kind of 0. So really what we're left with is the centripetal force, the force that is aimed, we're keeping it in a circle, the centripetal force, or the centripetal force is the force of gravity. Alright, that is the only force there, because we're barely touching the surface, so that's why that kind of crosses out to 0. And so let's break this down. Let's go forward with this. Centripetal force is defined by the mass times the tangential speed squared over the radius equals mass times gravity. And since we want to know the minimum speed, we want to isolate here the tangential speed. And if we try to isolate that variable, let's see what we get here. Well, certainly the masses crosses out. So the minimum speed that we need to sustain here looks like a tangential speed equals to the square root of the radius times gravity. Right, and the only value that we're given this problem is the radius of this loop, which is 2.7. Right. So in this problem, it's the tangential speed is going to be the square root of 2.5 meters times 9.8 meters per second squared. Let me drag that square root a little further down. And it looks like the answer, well, if we do 2.5 times 9.8 and then we square root that, it is going to be 4.95. And this is the speed the biker, or the stunt person, has to maintain so that they remain on the loop. Alright guys, I hope that was helpful. Please let me know if you have any questions.